Hello and welcome to problem set number 4, the periodic table, isotopes, and electron configuration. I do highly recommend that you have the worksheet available from my website printed off in front of you as we go through these problems. So with that said, let's go ahead and get started. All right, number 1. What element resides in group 7, period 2? So fortunately, I have my periodic table available here. You will definitely need a periodic table for this problem set. So we've got group 7 and period 2. Okay, so that is the element fluorine. I'm going to write the symbol here, F. Okay. Problem number 2. What is the collective name for the group 8A elements? Those are called the noble gases. Okay. Number 3. What is the atomic mass of nitrogen? So that is a number that you can find from the periodic table. Okay, remember that that is the number that is not going to be a whole number because it is a weighted average for all the naturally occurring isotopes of that element. So make sure you're looking at the atomic mass, not the atomic number. Okay, so the atomic mass is 14.0 and that's atomic mass units. On my periodic table, you may have a periodic table that goes out to more decimal places and has a little more precision. That's great. So record all the decimal places that your periodic table has. Mine just goes out to the 1. All right, number 4. How many protons does a lithium atom have? So we're going to find lithium on the periodic table and we're going to look at its atomic number. Remember that the atomic number is always the whole number in the periodic table and it's going to tell you how many protons are in the nucleus of one atom of that element. So for lithium, it is 3. Okay. Number 5. What is the atomic number of magnesium? So magnesium is right here. So look for magnesium on your periodic table. And remember the atomic number is the whole number. It's going to tell you how many protons are in the nucleus of that atom. And for this particular element, it is 12. Okay. Number 6. A neutral atom has an atomic number of 7. Okay, so atomic number, remember, is symbolized as Z. Okay, and a mass number, remember that that's symbolized as A, of 15. How many protons, neutrons, and electrons does it have? Write the element symbol and to represent this isotope correctly and include the atomic and mass numbers. Okay, so it must have 7 protons. And then remember that the mass number is the sum of the protons and the neutrons. Okay, so the number of protons equals 7. The number of neutrons equals 15 minus 7, or 8. Okay, so now when we want to write this element symbol, we can look and see on the periodic table which element is atomic number 7. Okay, so check on your periodic table, atomic number 7, that is the element nitrogen. So for our symbol, we're going to write N for nitrogen. We want to represent that it's a specific isotope of nitrogen. So remember the mass number is a superscript written before the element symbol, and the atomic number is a subscript written before the element symbol. So this is the proper symbol for nitrogen 15, the isotope of nitrogen, which has 8 neutrons. All right, I think we did all the problems there. Oh, electrons. We didn't do the electrons, sorry. The number of electrons, because this is a neutral atom of nitrogen, the number of electrons is going to be the same as the number of protons. So the number of electrons is also going to be 7. Notice that it says a neutral atom at the beginning of the problem. All right. Number 7, let's go up here. Number 7, write the element symbol to represent the following isotopes. A, carbon 14. B, barium 138. C, fluorine 19. And D, oops, that's the same as B. Go ahead and erase D. We won't do D. All right. So A, B, and C here. Carbon 14. Okay, so we're going to write the element symbol, C, and we know which isotope of carbon it is because that's given in the problem. So we're going to write the 14 as a superscript before the element symbol. And then we also want to write the atomic number as a subscript before the element symbol. So that's the proper way to write the symbol for carbon 14 for when we need to write it in things like nuclear equations. All right, barium 138. All right, Ba is a symbol. 138 is the mass number. Now we just need to look at the periodic table and find out the atomic number. It is 56. Okay, so there's the proper way to write the symbol for barium 138. All right, fluorine 19. The element symbol is capital F. And let's look up the atomic number. The atomic number is 9. Okay. All right, let's go ahead and erase all this before we go on to number 8 because boy, are we going to need some room to do number 8. All right, number 8. How many protons, neutrons, and electrons are in the following? And there's an A through G, so it's going to take a lot of room here. A. I'll write them all out first. Here's B, C, D, E, F, G. All right. Okay, so I purposely did not put the atomic number in because I wanted to make you do a little bit more work. So let's start with A. Number of protons, number of neutrons, and number of electrons for this neutral lithium atom. All right, so we can look at the periodic table for lithium, look up the atomic number, it's 3, so now we know the number of protons. We're given the mass number, so we know the mass number for this particular isotope of lithium is 7. And remember that that is a sum of the protons and the neutrons, so subtract out the number of protons and you will find the number of neutrons, which is 4. Now because it's a neutral atom, we know that the number of protons is equal to the number of electrons, so there must also be 3 negatively charged particles to balance out the 3 positively charged protons. All right, B, phosphorus. All right, so let's look up phosphorus over here. The atomic number is 15, so the number of protons in any phosphorus atom, doesn't matter which isotope it is, the number of protons is going to be 15 for this element. The number of neutrons can be found by subtracting the mass number, subtracting the atomic number from the mass number. So subtract out the 15 and you'll find that there are 16 neutrons in this particular isotope. And because it is a neutral atom of phosphorus, the number of electrons and the number of protons must be the same. All right, now we get to a cation. Number of electrons and protons are not going to be the same. Okay. All right, so let's look up the atomic number for potassium. It is 19. So the number of protons is equal to the atomic number, so 19. The number of neutrons, we have to subtract the atomic number from the mass number. And what do we get there? 20 neutrons in this particular isotope. And the number of electrons is no longer equal to the number of protons. Okay? There must be one greater proton content than electrons because there's a 1 plus charge. So we have lost an electron from the neutral atom to form this cation. So there are only 18 negatively charged electrons. 19 positive charge, 18 negative charges, so overall a 1 plus charge. All right, calcium here. Look up the atomic number for calcium. You'll have the number of protons. It's 20. 41 minus 20 gives you the number of neutrons, which is 21. Calcium has a 2 plus charge in this particular example, so we have 2 greater proton content than electron content. We've lost 2 electrons, in other words, so only 18 negatively charged electrons. All right, helium here. The atomic number for helium is 2, so protons equal 2. Okay, so the neutrons, 2 minus 2, must be 0. And the electron in this case would be equal to the number of protons. So 2 negatively charged electrons and 2 positively charged protons. All right, hydrogen. All right, the number of protons is equal to the atomic number. The atomic number is 1, so 1 proton. The number of neutrons is going to be the mass number minus the atomic number, so 2 neutrons. And because it is neutral, the number of electrons is going to be equal to the number of protons, so just 1. All right, oxygen. Look up the atomic number. It is 8, so the number of protons is 8. The number of neutrons is going to be 16 minus 8, so 8. And the number of electrons is going to be 2 greater than the number of protons. We have gained 2 electrons, so 10 negatively charged particles and only 8 positively charged protons, so overall a 2 minus charge. Okay. Whew, that was a lot of work. All right, let's erase all of this and go on to number 9. All right, number 9. Write the electron configuration for the following neutral atoms. Okay, so we've got A, C, B, oxygen, C, sodium, D, chlorine. All right. All right, so we're going to need our periodic table here. So writing the electron configuration for carbon. Carbon is here. Remember how I showed you to use your periodic table? The first 2 columns with helium pulled over here represent your S block. The rest of the main group is your P block. And then your energy levels are the period numbers. Okay, so going all the way down to carbon, we're starting at hydrogen. So we've got 1s2. I just counted over, done, done. So now we're at the second energy level, 2, still in the S block, counted over, 2s2. There are 2 electrons in the second energy level, S sublevel. Now go all the way over, we're just counting all the way down to carbon. We're still in the second energy level, but now we're in the P block. So 2p, it's not filled, it's just 1, 2. Count over to carbon, that's 2 places. Okay, so you can always check your work here. Carbon, if it's a neutral atom, has 6 electrons. So we should be accounting for 6 electrons, 2, 4, 6. Remember that the superscripts represent how many electrons are in that particular energy level, sublevel. All right, let's do oxygen. So now we're going all the way to here. Okay, so start at hydrogen. 1s2, keep going. 2s2, keep going. 2p, 1, 2, 3, 4. We're at oxygen, so that's where we stop. 2p4. Okay. Sodium. Going all the way down here. Okay. Aren't you glad we're not drawing those pictures of the energy levels and sublevels? That would be very hard to do. Thank goodness for electron configurations. All right, starting with hydrogen. 1s2, 2s2. Okay, so we went through 1s2, 2s2. Now we're in the 2p, 2p, 1, 2, 3, 4, 5, 6. It's full. Keep going. 3, we're in the third energy level, S sublevel. 1 element here to get to sodium. So 3s1. Just 1 electron in that third energy level, S sublevel. All right, chlorine. All the way to here. Whew, it's going to take a while. Let's go ahead and do this one in the full electron configuration, and then I'm going to do the shorthand notation as well, just to sort of reinforce that, because that can be very helpful when these electron configurations get long. So let's do the full one first. 1s2, go down to 2, 2s2, still in the 2, it's full, so 2p6, all the way down to 3, so 3s2, we're counting all the way over to chlorine, so still in the 3, 3p now, 1, 2, 3, 4, 5, 3p5, okay. So I'm going to go ahead and do the shorthand notation for this one as well, because it can really save you a lot of time if you're doing an exam or a quiz. So remember, for the shorthand notation, we're doing chlorine. We can go back to the most recent noble gas, which is neon. We can say it has everything that neon has, plus 3s2, 3p5. So 3s2, 3p5. So this would be the shorthand. All right, number 10. How many valence electrons do each of the following neutral atoms have? And it's actually all the same ones that we just wrote electron configurations for. So that's why I purposely left that up here. So let's do number 10 right up here, next to number 9. And I'm going to use a different color. Let's use the blue. Remember that, remember that the valence electrons are the electrons in the outermost energy level, okay? So for the case of carbon, the valence electrons are in the second energy level. So that would be the 2 here and the 2 here. So for A, carbon has 4 valence electrons. B, oxygen has 2 plus 4, 6 valence electrons. C, sodium, the third energy level is the outermost. It just has 1 valence electron. And D, chlorine, the third energy level, 2 plus 5, 7 valence electrons. Now, if you're paying really close attention to your periodic table, you'll see that the number of valence electrons corresponds to the group number. Okay, and we'll talk about that a little bit more in the next tutorial, but just take a minute to look at carbon, group 4, 4 valence electrons. Oxygen, it's in group 6, 6 valence electrons. Sodium and all the other alkali metals, group 1, 1 valence electron. And chlorine, group 7, 7 valence electrons. So the group number will also tell you the number of valence electrons. So a much easier way to get that answer than writing out a full electron configuration. All right, number 11. I think we can squeak that in right here. Okay, I'm not going to erase. How many valence electrons do the halogens have? Okay, so the halogens are the group 7 nonmetals here. Okay, group 7 elements. So group 7, therefore 7 valence electrons. If you really want to do it the long way, you can write out all the electron configurations. You'll see that regardless of what the halogen is, whether it's fluorine or chlorine or bromine or iodine, doesn't matter. They all are going to have 2 in their outermost S and 5 in their outermost P sublevels. Okay, so the outermost energy level, 2 in the S, 5 in the P. 2 plus 5, 7. Easier to just look at the group number. Okay? All right. That concludes our problem set number 4. Thank you very much for tuning in.